Back again in the PLC Professor's Lab Workshop where we are discussing add-on instructions. We broke this into two parts. This is the second and last section on add-on instructions. So let's jump right in there and give it a whirl. We're going to continue where we left off in part one. If you've just dropped into these videos at this point, you're missing a lot of other information. I don't know if this video will help you. So if you are watching it and it doesn't make any sense, you need to watch part one. If that doesn't make any sense, then you have probably not done the actual projects in the lab manual that you need before you watch these videos. Regardless, thank you for watching. When we left part one, we had just added this logic, which is the interface to the add-on instruction. We also, and I will geezer this down a little bit so you can see at least one of these and the add-on instruction. The name of the instance of the class of objects cylinder over here, add-on instructions, is cylinder 1. Now in reality it might be the part insert cylinder or some other more appropriate name. And of course that cylinder, the name of the cylinder follows suit. So we named our tag cylinder 1 extend solenoid, cylinder 1 extended switch, that's a proc switch, cylinder 1 retracted solenoid, cylinder 1 retracted switch. And then we have the machine reset. I have this attached to an input, to a push button, but it might be the result of logic that looks at many different conditions in the whole system in order to allow a reset. In other words, to reset the fault that this were caused by this add-on instruction. Then also visible, but not affecting any changes outside the add-on instruction, is the retract warning ET and the actual retract ET, as well as the same for extend. So the extend ET, in this case it shows 0, but it'll show a different value after we run the logic. This will show you how long it took the cylinder to extend on its last execution. And this is the calculated warning value. Now remember, I set these presets for these timers quite high so we could actually observe them. The actual extend warning ET and retract warning ET would be quite a bit lower, probably more on the order of 1 to 1 1/4 seconds. And then we also made extended and retracted, not just output parameters, so we could use them here in the logic. See here, cylinder 1 extended, that's that bit right there. But we made them visible, so if you're troubleshooting, you can see if you caused a warning, extend, retract, or false, and you can see whether the logic thinks it's extended or retracting without actually opening up the logic. And again, there's two ways to open up the logic. By right click, I can go to properties, and I can see the parameters, and I can see the tag for the instruction. If I right click, and you can't see, it's because it's off of the screen, so I'm going to have to drag this down. This is very annoying. See, open instruction logic. We opened properties already. Open instruction definition. We can drag this out so we can see everything. Not only can we see the parameters, the local tags, the signature, which we don't have one yet because I never generated one. I'm not going to bother to generate one. And then change history. And this was created May 20th at roughly 10:07 a.m. And you can see that I edited it today at 9:34. And I could clear the identities, but I'm not going to mess with any of this stuff over here. And by the way, the help, what's here was generated automatically from the configuration of your add-on instruction. If you want something more specific, then you can add it in. So back to parameters. I can click on this button here to open up the logic to look at it, Or, as I more typically do, I just right-click on the instruction and open instruction logic. I can see that the extended switch is turned on right now, and I look over at my demo and it's not turned on. And then the next thing I look over and I go, oh, well, Tim, you're offline. So let's download this. Who active? Download. Now I'm going to pause this so you don't have to watch the download. Okay, I downloaded and went back into the run mode. I'm going to right click, and you can't see it. Well, I'll move this down. Right click, open instruction logic. So now we can watch this execute. Now remember, cylinder extend solenoid is a input parameter that looks at the state of the bit in memory that controls the output to the double solenoid valve body that controls extend and retract. I'm going to push a button here, and you can't, well, we'll go back to the main routine here. We'll try to make this a little cleaner. We'll watch this first. I'm going to push this button, which is input 3, data bit 3, and because it's okay to extend and we're not faulted, that will turn on this bit, which tells the solenoid to pull the valve, the shift to the spool over in the valve and extend the cylinder. The very next scan, or same scan, this is true because the switch is not extended yet. That seals it in so I can let go of the button. So I'm going to push the button. You can see it went on temporarily, but the extend solenoid is still on. Now I'll turn on the extended switch. And you can see after 2 seconds it goes off. And the reason it goes off is because the reason it took 2 seconds to go off is because of the 2 seconds in the debounce timer. So that's a little confusing if you're sitting out here watching this logic. But I want to go through this logic one more time. We're using a push button to do a manual extend. This bit comes on, which seals in the logic through the cylinder 1 extended. Now remember, extended and retracted. Now let's go back to the logic. See, extended and retracted. Okay, now I'm going to turn that switch back off. There's a toggle switch that's simulating the proc switch on the cylinder. And this 2 seconds right here is what makes this whole thing look odd. Both these timers start at the same time. The instant that you turn on the extend solenoid, this timer starts. I misspoke myself. They don't both start at the same time. This timer times until the switch is the extended switch is made, and the debounce timer is timed out. So when you tell the solenoid to extend the cylinder, this timer times until it's extended, but it's not extended until 2 seconds after the switch is actually made. This is the debounce. In reality, it's probably 1/10 of a second. If it was 1/10 of a second, you wouldn't even notice it. I made it 2 seconds, and I made this 10 seconds so we can see the action. Let's try that again. So I'm going to push input 3, or we'll say bit 3, and you see that it's accumulating. Now I'm going to make the switch, and as soon as I make the switch, this starts accumulating, and as soon as it's done, this bit comes on. It also captures the actual value, but that is the total time. See, cylinder extending accumulate, not debounce accumulate. This starts the instant that you energize a solenoid, and it stops 2 seconds after the switch is made. So now that you've seen that function, you've actually seen that accumulate. We'll do it one more time. Now we did get a warning because we went over 75. Now it doesn't look like we did, but we did. I know this says 7352, but you have to remember the order that this all executes in. We're talking about thousandths of a second. So 7.3 seconds versus 7.5. If I wanted to shift the logic around in this rung, I could make it look different. Let's do that again. We'll clear it. We'll put 0 in there. And that's good. I'm going to turn off the switch. Cylinder extend switch. So first we're going to energize this bit. That will start this timer. It'll start accumulating. When this switch is made, 2 seconds later, done bit, extended, this goes false, this stops. We also, on a one shot, when this is extended, we capture the present ET. Now remember that this accumulate value starts the instant that the solenoid comes on, not from the time you hit the switch until it stops. This is the extending, it's measuring the extended ET. So I'm going to push input 3, so watch cylinder extend solenoid. Now I'm going to make the switch. Now you see this is timing, and it captured 4697. So that's how long it took to extend, and that includes this 2 seconds. So really, it only took 2.6 seconds, 2.7 seconds to extend. But we said it really wasn't extended until this 2 seconds was up. Now let's drop this down to 100, which is 1/10 of a second. Same thing down here. And we'll make this, we'll make it 5,000, which is 5 seconds. That's longer than what you would normally see, but we need something long enough to be able to see the action. Let's try this again. So I'm going to push input 3, and I'm immediately going to make the switch, and then 1/10 of a second later it captured the ET. That means that it actually took 2.286 seconds to extend, but remember we had this 100 milliseconds in there for debounce. Now in most cases the debounce isn't necessary. Remember that we try to come up with a feature-rich add-on instruction that look for everything, including faults and warnings. Now we did get a warning in the previous execution, and this is going to stay latched until we hit the reset button. So watch that bit right there, the warning. I push reset, and now it's cleared. You would get the exact same action with retract. So we're not going to bother running this logic. And remember that this is all about creating add-on instructions, not using them. But I just want to give you a crude demonstration that this add-on instruction does function. And remember, some of the things that we're looking at here probably aren't necessary. So we could make this instruction smaller if we wanted to remove some of the things that are visible, like the retract warning ET, since that is calculated based on what we set the actual timers to. It's probably not necessary to view that. So just for grins, I'm going to save this, including the database. I'm going to pause and then come back. We saved it. Now we're going to go offline. And now I'm going to, we'll go to the actual class of objects, right click on cylinder, open definition, and we'll go to parameters, and we will turn off the visibility for the ETs for the warnings, because those are just calculated values. Now watch over here when we hit apply and OK. You see we just shortened up that instruction to, for the most part, what we want. Now these don't have to be visible. They're kind of a nice troubleshooting tool because you can see how long it's taking to extend and retract. However, if you were displaying these on an HMI, you know, MMI, OIT, human machine interface, like Factory Talk View, ME, you really wouldn't have to display them here. But for the person doing the troubleshooting who went and got their laptop and they're trying to figure out why this machine's not functioning correctly, having them right here is not all bad, even though it does take up screen space when you're trying to see as much logic in here as possible. We're going to do a couple things here. In the lab project manual, I showed you how to export and import add-on instructions, so we'll do that first. So let's make that a little bit smaller so we can see what we're doing over here. So we go to Cylinder, we right-click on Cylinder, and we go to Export Add-on Instruction. And then it comes up. I have it going to Archive for Recording, but you could put that in, I told you to put it in Learn RS5000. And it's called Cylinder. We probably already have one in there. I'm going to say Export anyway. Now it's exported into the folder Learn RS5000, the same place your programs, your projects have gone. Now we're going to create a new project. So we'll minimize this one and we'll create a new one, and I will pause rather than making you watch that. So I'm creating a new project, same processor, same revision level, titled More Cylinders. I add a little on the end just so if I already have more cylinders in Learn 5000. So we'll go to Computer, go to PLC Professor, there we go. So I create the new project. We have a new project created. We're going to go to Add-on Instructions, right-click, Import Add-on Instructions. And of course you have to know where you saved it to. And there we have it right there. And I know that it's the correct one because it's May 21st. So we click and select that one. And we click on, let me pull this into view here. Import. And I know it's not imported yet because I don't see a plus sign over here. So once this pops up, we click OK. You could have done some revision work right there if you wanted to. We're keeping this simple. Now we have an add-on instruction over here. Next in our lab project, we had you create a new project, and we're going to import the add-on instruction cylinder, SCYL, and we're going to use this as our new application, tandem cylinders. Now there's many ways that this can be done. The actual device in front of you, a Parker cylinder, it really doesn't matter whether it's pneumatic or hydraulic. But what you're looking at really is two cylinders bolted together back to back. These tie rods right here, you see the nut on this end, you see bolt heads or nuts on the other end. These four rods here are tie rods. So they really clamp all these pieces together, but you have two individual cylinders here. Here's the two ports for this cylinder and the two ports for this cylinder. Now if you try to picture in your mind how this is going to work, that would be this example up here. If, however, this was a single-ended cylinder, in other words, the rod did not extend out this end, this was closed off, and this cylinder piston could go back and forth, and it would influence this piston back and forth, then you would have something more like this, where you have three positions, both of them retracted, one extended, the other one basically neutral. It's not retracted, it's not extended, it's partway in between. And then here, both of them are extended in this example here. If you're looking at this image in the upper left-hand corner, on the left you see a 3 position, but that's not this actual cylinder you're looking at. This cylinder would be the one that's shown, this cylinder would be the one actually shown on the right side. This would be another possibility. What we have here are 2 pneumatic slides. In this case, the cylinder moves, but the base does not. So those 2 rods you see sticking out of the upper part, those are the rods. It's a dual rod cylinder. So the upper half of this slides back and forth under shifting of air pressure. Well, we could take one of these and mount it right on top of the other one, and so the bottom one moves the top one back and forth, and then the top one moves its slide back and forth. That gives you 4 positions. Now, if these are both the same length, you might end up with 3 positions, but we'll assume 4 positions. All right, here's our application. We have 4 proc switches and 2 cylinders. Now, it really doesn't matter how these cylinders are mechanically connected. It's enough to say that cylinder A, the one on the left, influences the position of cylinder B, the one on the right. So cylinder A, the one on the left, is stationary, and cylinder B, the one on the right, its position is changed by the position of the piston in cylinder A. So here you have 4 positions, both retracted, and then position 1 you have cylinder A extended, cylinder B retracted, and then in position 2 you have cylinder A retracted, cylinder B extended, and then in position 3 you have both cylinders extended. And this gives you 4 different positions. Now you'll notice that the difference between position 1 and position 2 is not that much, and that would be determined by the stroke of the cylinder, not the length of the rod, but the actual travel of the piston inside the cylinder sleeve. So this is our application that we're going to do next. We exported an add-on instruction, and then we created a new project, more controllers. We imported that add-on instruction in, and see you have it here, cylinders. You can see there's nothing in the main routine yet. That's what we're going to do next, is we're going to add some logic. I'm going to add most of this offline. I'll pause and then come back. Okay, we've added these 4 rungs of logic, and remember we have 2 cylinders, and each cylinder has a dual solenoid valve body. Each cylinder has an extend and a retract. We have them labeled here: retract base, retract rider, extend base, extend rider. These are the outputs to the solenoid valve. The base is the stationary cylinder, and the rider is the one that rides on the effect of cylinder A or the base's extend and retract. Because we have 4 positions, we have created 4 bits that are controlled by logic somewhere else that request position 0, position 1, position 2, or position 3. So remember, position 0 was both the base and the rider retracted. And if you look, you can see that position 0 is used in rungs 0 and 1 to retract the rider and to retract the base. Position 1, the rider is still retracted, but the base is extended. In position 2, we retract the base and then we extend the rider. And in position 3, both the base and the rider are extended. Let's add another rung of logic. We're doing this offline. You could do it online. And in this case, we want to add add-on instructions. Add-on, we've only got 1 cylinder, but we're going to put 2 in there. And we're going to call this one base. And define it as a cylinder data type. You have add-on instructions, and you also have add-on defined data types. So this data type here, this data structure, backs this add-on instruction up here. So we'll say create, and then this one, of course, is going to be rider. Again, a data type cylinder, create. Now we have to associate some of these tags up here into the add-on instruction. This is the base and this is the writer. First we'll go up here and we'll grab the retract base tag. We'll drag it down to cylinder retract solenoid, and then extend base right there. That takes care of two of them. Now the switches are a different story. So as long as we're right here, this is the extend writer and retract writer. For the switches, the extend and retract switches for both cylinders, we're going to type these in. I'll do one and then pause and do the other three without making you watch. So the first one will be the base underscore extend switch. And I'm going to create that new tag. It's going to be an alias. Type in LO for local just to get in the right ballpark. It's an input data, and we gave it bit 1. Okay, now I'm going to pause and do the rest of them. Here we have the rungs finished. We have two cylinder add-on instructions, one for the base, one for the writer. I've associated all of the required parameters to actual I/O, including the machine reset. Now in the lab manual, we did something slightly different. But again, I want to remind you, this is about creating add-on instructions, not using them. So I don't hold real tight and true with exactly what I did in the lab manual when it comes to the demonstration. At this point, you should be knowledgeable enough in especially ladder logic diagrams, and by now with RS5000 that you could have gone ahead and done a lot of this any way that you wanted. So we're just creating a demonstration here, not showing you how to use them. We're just using them to demonstrate them. So now we have 1, 2, 3, 4, 5, 6, 7 rungs of logic, and then I had you add 4 more rungs. Now I didn't explain these two here, but I think they're self-evident. Because the extend and retract switches are executed, they're used in logic inside of these two add-on instructions. Neither of these extend switches for the base or the writer really say what the whole assembly is as far as its position. So really we're working with 4 positions. As you see up here, we're requesting position 0, 1, 2, or 3. And then we, if you want to encode that into which solenoids to energize to either retract or extend one of those 2 cylinders. And then down here we say if the base is retracted, and remember that this is a direct result of a debounce timer off of this proc switch. If your base is retracted and your writer is retracted, then you're in position 0. If the base is retracted and the writer is extended, then you're in position 2. And of course here's the other 2 positions here, position 1, position. Now I'm going to pause and add 4 more rungs of logic. Just as we marshaled the state of the proc switches to say we're in position 0, 1, 2, or 3, we are also marshaling the warnings and the faults to say that we have a retract warning, extend warning, retract fault, extend fault. We're treating the tandem cylinders, or piggyback cylinders, sometimes they're called, we're treating that as one device. And we either have a warning on an extend or retract, or we have a fault on extend or retract. Now we're going to save and download. Go to communications, who active, make sure I can see my processor. If this doesn't gray out, then we're good. So we're going to say download. I'm going to pause, finish the download, and then come back. I did this to point out that remember, this is not in the add-on instruction yet. We've not nested these add-on instructions. But something I want you to notice, that this logic that marshals the retracted and extended condition of each of these cylinders shows that you're in no position right now. And if I flip the switches, it's not going to show a position, simply because as far as this logic is concerned, you're not extended or retracted. If we open up one of these and go to the logic, you'll see that we aren't going to get the extended bit or the retracted bit until we actually try to extend or retract. We created this logic in the main routine, but we're going to do something slightly different with it. And I know I'm not following the exact same pattern in the manual, but it will still work out the same. I'm going to go back offline. I didn't really change anything, so there's no reason to save. And I'm going to go to add-on instructions, new add-on instructions, and I'm going to call it tandem cylinder. Okay. And I'm going to select the logic now. Now this is the logic for the add-on instruction. Now open the main routine, which is right here, and do a Control A. That selects everything. Control A, Control C, that copies everything. And then in the logic, do a Control V. And now we have these 12 rungs of logic in the class of object tandem cylinders. Now we had you alias some of the I/O to enable testing the logic before you committed it to an add-on instruction. What I'm demonstrating here is creating an add-on instruction, not using it. And it is better to create your logic in a routine and test it, then move it into an add-on instruction. And you're going to have to repeat the process of defining parameters. However, that will strengthen your use of the tools, so repetition is not a problem. Now, you may run into a situation where the logic worked in a routine and it does not work in an add-on instruction. However, most of it will have been debugged before you put it into the add-on instruction, so the only things that you have left are things that won't work because of transitional instructions. Next thing we had you do is to define the tags within the add-on instruction. Now you already defined them, but that was within the program tags or the controller tags. Now we're going to define them as parameters or local tags. First, we're going to define all of these as input parameters. There's only 4 there, even though you see 8 as position 0, 1, 2, and 3 request. So I'm going to right-click, and it's an input parameter. It's already selected input parameter, so that works. Okay. New input parameter. Okay. New input parameter, okay, and that leaves us this one. New parameter, input parameter, okay. So now we've got these 4 defined as input parameters. These are going to be output parameters. Now there's many different ways you can do this. When you start playing with these add-on instructions, you're going to see that there are hundreds of possible variations to what you make an input-output parameter, an input parameter, output parameter, or a local tag. For now, I'm going to make these output parameters. If you make a mistake, you can always come back and change these. However, you do have to do it offline. We'll delete that unused rung just to clean it up. This is a input parameter. This is an input parameter. And machine reset is an input parameter. That one's already defined. This is an output parameter, and we don't really have it defined yet, and that is view only. It's worthwhile to note that when you created or you move these two add-on instructions from a routine into an add-on instruction to nest them, that you may have to go and edit each one of these instances of this class of objects and make it a cylinder type data type. It may come up as a local Boolean tag. So just a heads up that although you defined this as a cylinder data type when it was in the routine, when you copy and pasted it into an add-on instruction, you may have to go redefine base and writer. So if you were going through your project and you ran into a problem where you couldn't get rid of the edit E's along this rung and these rungs down here, it was because these weren't properly defined, and because they weren't properly defined, then any tags in these rungs that are parameters from these two add-on instructions also would be undefined. Just wanted to point that out. Remember, this is about creating add-on instructions. Now, the convolution here, the complexity, is that you have to be conscious that an add-on instruction is a world unto itself. So here we have two private domains of the class of objects cylinder, but they're nested inside another class of objects, tandem cylinders, which adds another level of complexity. So each one of these has its own database, its own local tags, and then it has input and output parameters. This one does as well. So if we go back to the main routine now, and let's delete this logic now that we have it in our logic of our add-on instruction. We can close this routine. Now we're left with the main routine. So we really don't have any logic. All we did was create a new add-on instruction by nesting two add-on instructions that we had imported from the previous project. While you're at it, you might as well export this It's slightly out of view, so I'm going to, I guess you can just barely see it. Export add-on instruction. And we're going to export it to the same place, only it's going to be tandem cylinders. Export. Save your project. And there you have created an add-on instruction with nested add-on instructions. Now that we've finished that, we've saved this. Let's close this down and create another new project called Tandem Cylinders. We created a project, created an add-on instruction, exported it, created a new project, imported it, created another add-on instruction, exported it. Now we're going to create another project, Tandem Cylinders, and import our new nested add-on instruction. There's our new project. And we also need to add I/O cards. Open up our main routine. Here we have an unfinished rung. We're going to go up to add-on, and guess what? We forgot to, no, you didn't. I forgot to import. So we'll go to add-on instructions, and I'm going to import both cylinder and tandem cylinder. I guess it's only going to let me import one at a time. It's easy to forget this step. We're so accustomed to having all of the instructions as predefined that we forget that if you create an add-on instruction, it does not get into other projects unless you first export it and then import it. So now we're going to go up here and see we have cylinder and tandem cylinder. Now, text-wise, that didn't work out very well there, did it? So maybe we might want to go back and change the name of that from tandem cylinders to something that's 3 or 4 characters long. But we'll click on that, and there we have one. Now we want to create an instance. We'll call it group 1. That's what we did in the lab. And we're going to define that as a tandem cylinders data type. Now, that looks okay, but we really don't have anything yet. Now we have to open up the definition, and we have to do all of our visibility and required selections. We have more selections now, so we can't get them all on the screen. We drag this out. And let's go through and consider these. This is going to be, it's an input parameter, so it's going to be required. Any kind of input or output parameters are going to be required. That does give us quite a cumbersome instruction, doesn't it? Okay, here is our huge add-on instruction. And now we have to create tags to alias to this. Once you've done all this and created this instruction, when it comes to actually using it, it's not as bad as it looks, because you can drag most of the tags into this instruction. I'm going to pause and associate tags with these parameters. I just noticed some of these things should be visible but not required. That'll reduce this down to a more manageable size. So I'm going to pause and correct those things, like the actual, some values we want to, like the warning and the faults, we want to see those off to the side, but we don't need those as required. Now you see that I've made some of them visible but not required. We want to see that we're in position 0, 1, 2, or 3. We want to see the warnings and the faults, but we don't need them required as far as an interface outside of this instruction beyond just the visibility. I'm going to have to create 4 new tags for the position request bits. Remember, these bits bring in the request outside of the instruction to go to a certain position. So I'm going to have to go create go-to bits, and then I will associate those with input switches so we can operate them. Okay, now we have associated tags with all of our requirements, and we have a happy add-on instruction. And if we open up the logic, we have to scroll down a little bit so you can see that. Open instruction logic. There's our logic that makes up the add-on instruction, and within the add-on instruction, I'll scroll up so I can do that in your sight. I'm inside an add-on instruction. I'm right-clicking on an add-on instruction inside of the add-on instruction. You still can't see down there, so I have to scroll down a little bit further. Right-click. See how it jumps down? It's just not going to let me do. Oh, there it is. right there, open instruction logic. So now we're looking at the logic inside of the logic inside of the add-on instruction. So we don't have any revolutionary new add-on logic here. These are the add-on instructions we created in the previous project. We exported, imported, and then put them into an add-on instruction. This logic that marshals a request for a particular position and then supplies the commands to these two instructions. And then here we marshal the positions into the actual switch positions of each individual cylinder into position 0, 1, 2, or 3. And then here we marshal the warnings and the faults. Here's our tandem cylinders instruction with all of the required parameters associated with tags. I've also added some automation. The first rung that has really no execution. That's why it has a no-op. The NOP instruction at the end. Whenever you see that at the end, that usually means that it's kind of a down and dirty version of an HMI. This allows me to see these four variables, these four tags, which are going to be used down here for sequencing the position of the cylinder in the logic. This allows me easy access to click on one of these and change the value. Well, I don't want 36,000, I meant 3,600. This rung takes the elapsed time in our sequence for position 0 and adds position 1 ET to it to give us complete 1. We do the same thing with then complete 1, we add position 2 to get complete 2, and then we add complete 2 and position 3 together to get complete 3. And down here in this logic, we enable the sequence and we start a timer. And we're using the accumulate value in these limit instructions. For the first position, we give it whatever value you typed in up here. And you could also type it in right there if you wanted to. So this is kind of unnecessary, except that we're only showing position 0 down here. We're not showing position 1 and 2 and 3. As the timer's timing, when the accumulate value is between 1 and position 0 elapsed time, we say go to position 0. When it's in position 0, and if the accumulate is between the end of position 0 ET plus whatever position 1 ETs is, that gives us complete 1, then we say go to position 1. And then down at the end here we have, if we're in position 3, then we unlatch the enable sequence bit and we reset the sequence driver timer. Or that can be done with the push button, which is the 10th push button. We have 10 push buttons, 10 toggle switches wired in parallel on our hardware demo. So this all works fine. Then we also have, we marshal, because we only have 10 lights to use, 10 LEDs. I only had 2 left, bit 8 and bit 9, and so I marshaled the 2 warnings together into 1 warning, the 2 faults into 1 fault. This logic works fine for the most part. However, I found something that I definitely do not like. Right click on this compound add-on instruction, open the logic, and you see this logic right here that determines that it's in position 0, 1, 2, or 3 that we would like to use out here, in position 0, in position 1, and so forth. The problem is they won't show up correctly because these tags right here, base retracted, base extended, rider retracted, writer extended. They are tags that are accessed out of these two add-on instructions that are nested in this add-on instruction. If I open up one of these, we'll scroll this up so you can see I'm clicking on Open Instruction Logic. The problem here is if I'm not telling it to extend, then none of this logic executes. Now this logic works fine in a routine, but in this situation we are not executing this logic. We want to use extended as our in position, not our switches. Now we could go back out here and use the switches here to do the in position, or we can go into the logic for the basic cylinder, this instruction over here, and change the logic. So that's what I'm going to do. You don't do it in the instance though. This is an instance right here, and this is the instance base and the instance writer. But here's what I want you to notice. When I open the logic, see where this instruction is at? It's at the head of the rung, and everything in the rung is controlled by that single bit. So I'm going to close these. We don't have to close these to do what I'm going to do. I'm going to go over to the logic for the class of objects. I'm going to open it, and I'm going to drag this down to here. And this down to here. My reasoning is that the debounce, the extended bit, and then capturing the actual ET is not dependent upon this extend solenoid being actuated. Now, since this is not logic that's actually running a real cylinder with switches, we have a bit of a challenge in that you can, by toggling bits and flipping switches, you can create a scenario that really cannot exist in the real world. So it's a bit of an entanglement. In the real world, this would work out fine. But here's what I want to show you, because remember, this is about creating add-on instructions, not using them. Part of the process of creating them is testing them, and that's what we're doing. We're testing this add-on instruction. I don't like the way it works, so I'm going to edit the add-on instruction. Now remember, this is not the instance. We're editing the class of objects over here. So I've made those changes. Now I'm going to go back and open up the instruction logic for the compound add-on instruction. And then I'm going to open up one of these. And notice the change that we made over here in the class of objects has been inherited by the actual use of that add-on instruction in logic. We'll right click on this one, do the same thing. Open instruction logic. You see, this is good because this demonstrates inheritance. So we made changes in the class of objects, and every place it was used in the logic inherited those changes. Now you can only do this offline. So I'm going to save, download, and then talk about it a little bit more. Okay, I made the changes that I showed you, and now the logic works reasonably well. When I say reasonably well, I've not found any faults in it, other than it is very difficult to execute this without stretching out the timers to give me time to think for flipping the switches. The only 4 switches that I really have to deal with are the 4 toggle switches that represent the positions of the cylinders. So right now, they're in extend. So now flip them, and both cylinders are retracted. So we've got these 4 toggle switches, and I try to give you some graphics in the manual to help you keep track of what you're doing with your actual I/O addresses or your switch positions. That's position 0. In position 1, which is the second position, the base cylinder is extending. The retracts, watch the line right here. Watch these 4 switches. The first thing you would see happen is the retract switch would go off because the cylinder is traveling, and then it would make the extend switch. So if we can get as much as we can in view here, I'll put that back. So here you see the 2 switches, the retract switches are made, so it says it's in position 0. If I turn off the retract, it's in no position now, and then turn on the extend, now it shows it's in position 1. And I'm going to, well, I'll just geezer this down. See if we can get them all in here. Now we've got them all in here. Here's the 4 switches and here's the in positions. Remember, it's the combination of these 4 switches that determines what position that it's in. So right now we're in position 1. In position 2, we have retracted the base cylinder and extended the rider. So see, base, retracted, rider, extended. Now we're in position 2. Position 3, they're both extended. See, now we're in position 3, they're both extended. Now the proper sequence for shifting the position of a cylinder is to turn off the switch that's on before you turn on the other one that's off. In other words, you have a retract and an extend. So if I was going to go back to position 0 from position 3, I would turn off both extend switches. See, they're both off. Right now all the switches are off because both cylinders are traveling. And then I would make the retracted switches when both cylinders are retracted. So if you're going to do this in an actual sequence that matches the real world, you got to sit down and really think this through and maybe draw up a chart and have it say switch 0 off, switch 1 on, etc., position such and such. I have included in the manual some graphics to help you out somewhat. And again, this is about creating and troubleshooting add-on instructions, not using them. You would not be doing this, what we're doing right here, at the point where you're actually using the add-on instruction. We're still troubleshooting and commissioning really the class of objects. We're doing it by putting it in code to test it. You have to put it in code in order to test it. So I'm not going to wrap this up with a real nice, neat, and tidy demonstration. I suppose that I could, since it's in position 0 right now, I could operate the switches while you watch the in positions and the lights. If I want to stretch this way out, I'm going to go to logic here. Now this is tandem cylinders logic, okay? This isn't the logic for the basic add-on instruction cylinder, but it's for tandem cylinders that has 2 of these nested. So I'm going to right click and I'll scroll this up. I think by now you know how to get there. Right click. Well, I'll tell you, doing this with RS-232 is crazy. Open instruction logic. Now I'm going to bump this timer preset up to 5 seconds. Now I'm going to leave it at, if these are the timers that determine whether you have a warning or a fault. Now this timer, if it times out, it gives you a fault. But remember, we're using 75% of the preset to say that we're cumulative reaches 75% of the preset, then we're declaring a warning. and it actually latches in the warning. If it times out, then we have a fault. So we'll leave this set at 3 seconds, both of these. So the only way that we can really extend out is we would have to change these to give us more time. But remember, if we take more than 3 seconds, if we take more than 75% of 3 seconds, which is what our extending and retracting timers are set at, so both switches are retracted, meaning that our cylinders are both retracted, so we're in position 0. If you look at the graphic in your manual, you'll see that if data point 0 is on and data point 2 is on, then you are in position 0. Now if I flip on one of these other switches, like the base extend, so now I got both retract and extend on. Well, that's impossible in the real world. And we can even add logic that declares a fault if both sensors, one at each end of the cylinder, are both on at the same time, because that means something's really wrong. But you see what happens down there in the logic. Now it says it's in position 0 and position 1. So we're assuming that you have some reasonable pragmatic approach to this, that you're not trying to extrapolate in all kinds of possibilities of other things that could fail, like the sensors shorting. So assuming the sensors are working correctly, right now we're in position 0. So I'm going to enable the sequence. Then I'm going to flip the switches, these two switches right here. Going from position 0 to position 1, all we're doing is extending the base cylinder. So I will enable the sequence, and then I will flip the switches, and now you see we're in position 1. Position 1 wants the two middle ones. I was too slow. See, I was too slow flipping the switches, so look what happened. I got retract, extend warning, retract fault, extend fault. Remember that I'm telling the cylinders to move, but there are no cylinders. It's up to me to flip the switches to say the cylinders got where we told them to go. So you see, this logic does work. I have been able to sequence it all the way through into position 3 to terminate the sequence. So the logic does work right. I think it's going to be pretty difficult. Well, I'll try it one more time. So I'm going to hit the reset button. Watch down here. See reset button? That clears the enable sequence bit, and it also clears the timer. Now that may not be necessary, because if you clear enable sequence, the run goes false and the timer resets. Resetting the sequence driver is not necessary. That instruction doesn't really need to be there. It's not doing anything. So let me start over in position. Okay, I'm in position 0. I toggle the bit, extend cylinder 1. Then I got a warning, but I was much too slow, because once it goes past the accumulate value of 10.6 seconds, then this logic's no longer going to execute. So I have to be faster. Enable sequence. I did get into position 2 this time before I started declaring faults. Anyway, enough of this. My conclusion, I have two conclusions. The first one is that this demonstrates how to nest add-on instructions in an add-on instruction. The initial add-on instruction, cylinder, is a practical application. Tandem cylinders is not a practical application, simply because there are not that many tandem cylinders used in a single process, much less processes at all. I have not seen one in quite a few years. But I thought it was a simple thing to understand what we were trying to accomplish. That's why I used it. The basic add-on instruction, cylinder, is a good application. And if I were you, I'd go back and tweak it to your liking. but I wouldn't bother with tandem cylinders. But you can see the challenges of add-on instructions embedded in add-on instructions. They start getting large because we have so many variables that have to go in there. And then when you open them up, you see these other two add-on instructions, and you can open those up and look at their logic as well. But remember that you have two levels of encapsulation here. Each of these encapsulates its own logic and its own database. In other words, the local tags. And then you have another level of encapsulation that encapsulates all of this. And remember that you have parameters. So some things that you may treat as an input-output parameter here, to get out in this area, you may or may not want to make that an input-output parameter out into the routine that the instruction is used in. Maybe we'll do some more with add-on instructions in Volume 3. This concludes Part 2, and it also includes the lab lecture discussion on add-on instructions. There are other lectures besides these two in this series on the subject of add-on instructions. I would advise that you watch those as well if you have not already. Actually, I recommend that you watch those other lectures first, do the lab, and then watch this lab wrap-up. I realize that this got a little loose towards the end because there is a lot of latitude for doing things completely different than the way I did them, especially in how you assign your parameters. I would advise you to, on your own, right now while it's fresh, play around with add-on instructions. Probably one of the best examples of an add-on instruction are where in ladder logic you want to do something with structured text or with function block diagrams, but you don't want to create a separate routine. Well, in a way, when you create a class of objects, and we'll say that you want to create an add-on instruction called tank temperature, and in that add-on instruction it's function block diagram, which is the good language to use for controlling the temperature of a tank. That instruction can be included in ladder logic. So this got to be kind of a complex application. Thank you for watching.